Let's start. Okay, so my topic was parametric equations to determine intersections in 2D and 3D vectors. And that's the first slide. So first, just as a reminder, how parametric equations look like in the 2D form and in the 3D form, and the only difference is that in the 3D form you have the z component, which makes it 3D. Which is that. And then, so let's say this is your vector line, this in the vector component form. Then your parametric equation, and this is your starting position, and the other part is your velocity, and then you have your t, your time. So, and then your parametric equation would look like this. You have also the x variable, y, and z, and you basically take this for your export and that. So this is how you get your parametric equation. And then the first step, which is good to know, is how to find a common point. So if, let's say you have the point 2, 3, 15 on another line or another object, and you still have this as your vector line, then you can simply just take this point and plug it into the parametric equations. That's basically why they exist, because it's easy to plug things in. And then what I did is here I plugged the 2 in for the x variable and then solved for t, and then plugged it back in and got 2 equals 2. And since I found t, I could simply plug it into the y component, get 3, and then in here get 15, and as you can see, it equals 3 equals 3, 15 equals 15. So you know that this point lies on the parametric equation or the vector line. So then an example in a 3D vector. So first you need to have your vector lines in the parametric equation. So I just took those two lines, line 1 and line 2, and those are the parametric equations for each of the lines. And well, exactly, and we have to keep in mind that there are 2 different variables for our time. In line 1 it is s, and in line 2 it's t. And basically, if you want to find the intersection of those 2 lines, you first put line 1 equal to line 2, which I did here. So for the x component, I took this part of line 1 and this part of line 2 and put them equal to each other. That's what I did for y and z as well. And then the next step is, since you gotta take 2 equations of the ones of the 3 above here to try to eliminate one of the variables and solve for the other one, and I did that in the next step. And yeah, I took the x and y component and I multiplied the y equation by 4 in order to get the plus 4t, so that in the next step the t variable is eliminated and I can simply solve for s. So that gives me the first variable that I can now go back to and plug into the other equation. So here I took the x equation from above here, I took it down and plugged the 3 in for the s variable and solved for t. So this automatically gave me my other variable that I had to find 2 in order to find the intersection. And then you basically go back to your first set of lines and then plug both of the variables that we just found in. So for line 1, I solved, by plugging in the 3 for the s, I solved here for x, y, and z, which gave me the point 7, 7, 8. And I did the same for line 2, plugged it in and then solved, and I got the same point. So that's the point where those 2 lines intersect, and you just found the intersection. That's a 3D, that's an example for a 3D vector. And now I got one more example in a 2D vector, and this is also an example for what parametric equations and finding intersections is quite useful for. In this case, like finding coordinates of a triangle ABC. And I already wrote down the coordinates for line AB. This one is right here, then BC and CA. And we want to try, in this case, find all the points. But just to make it short, because it's the same step for each point, we, in this case, are just going to solve for point B. give an example on how to do it. And in order to solve for point B, we need to choose the vector line for AB and BC, which I did here, and I already put them in the parametric equation again, because then by solving for those two, you find the intersection at the point B. And then I basically, as I did in the slide before, we put those two equal to each other. Yep. And then we gotta try to eliminate one of the variables again, which I did there. Well, it was already kind of in a good form because I didn't have to multiply this line or this line because they were already quite good. So I just eliminated the u, which then made it easy to solve for the t. So I already had my first variable, and now that we found that one, we can use it to plug it into the equation to get the other one, which is u, which I did here. So I plugged it in back into this equation, and then it gave me u, which was -1 in this case. And then I basically found the point 6,5 by plugging it back into this equation here. If you plug in the t, which we found here, into here we get x6, and then here we get yeah, 6 as well. Actually 5, sorry, for the y component. And yeah, if you do it with this line, we get the same. So we know that our point for b, the coordinates, is x equals 6 and y equals 5. And that's it. Yeah, and that's it for the quiz.
Good job.